Hi and welcome to day 7 of this year's Advent of Code. About 3 seconds to get started. And let's go. No space left on device. You can hear birds chirping and raindrops hitting leaves as the expedition proceeds. Occasionally, you can even hear much louder sounds in the distance. How big do the animals get out there anyway? The device the elves gave you has problems with more than just its communication system. You try to run a system update. System update, please, pretty please, with sugar on top. No space left on device. Perhaps you can delete some files to make space for the update. You browse around the file system to assess the situation and save the resulting terminal output, your puzzle input, for example. Take that as an example. We'll see what that means later on. The file system contains a tree of files, plain data, and directories which can contain other directories or files. The outermost directory is called /. You can navigate around the file system, moving into or out of directories and listing the content of the directory you're currently in. Within the terminal output, lines that begin with a $ are commands you can execute. Within the terminal output, lines with a $. Very much like some modern computers. CD means change directory. This changes the directory. This changes which directory is the current directory, but the specific result depends on the argument. CDX moves in one level. It looks in the current directory for a directory named X and makes it the current directory. CD moves out one level. It finds the directory that contains the current directory. Then makes a directory the current directory. CD/ switches the current directory to the outermost directory. ls means list. It prints out all of the files and directories immediately contained by the current directory. 1, 2, 3, ABC means that the current directory contains a file named ABC with size 1, 2, 3. Directory XYZ means that the current directory contains a directory named XYZ. Given the commands and output in the example above, you can determine that the file system visually looks like this. That's so to say the trace. CD/, then do a listing. Then we get this stuff, and the $ always means we execute the command, right? Okay, that makes sense. Here there are 4 directories, / the outermost directory, A and D, which are A and D, which are in / and E, which is in A. CDA, and then there's the directory E, that's fine. These directories also contain various files. Since the disk is full, your first step should probably be to find directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. The total size of a directory is the sum of the sizes of the files it contains. Directly or indirectly. Directories themselves do not count as having any intrinsic size. The total size of the directory above can be found as follows. The total size of directory E is blah 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 because it contains a single file. The directory A has a total size of 94,853 because it contains files F size. Directory D has a total size of... The outermost directory / contains every file. Its total size is forward the sum of the size of every file. What is the sum of the total sizes of those find all of the directories with a total size of at most. What is the sum of the total size of those directories? No, okay. Definitely a step up from yesterday. This limit here, I think, doesn't allow us to just count the files and ignore directories, or add up the file sizes and ignore directories. So yeah, in this case, I think our example output the calculation then calculate the sum of their total sizes. In the example above, these directories are A and E. The sum of their total sizes is this. So as in this example, this process can count files multiple, more than once. Yeah, this makes sense. So then we have our example input, and we can also already get our input. Oh, very large thing. So can keep our example up here, and the question now is a bit how we actually start here. I think it already makes sense to, if we do have CD, we only change, we can change back to root, but we don't do any changes that are like in more so I think a good thing here to have our file path actually set up as I'm not sure if directories can have unique names after all, but I think we for now can ignore this. So we'll set up our current path, which is a var, and it's our path, and it will be a mutable list of string. So that makes it easier to jump back and inside, rather than having the full file path as a string. Then we will just run through our commands. Yeah, otherwise they're called dir, right? Yeah, so it would just, for now, just write a loop where we say val command in lines, and I don't think we need that one here, and we check if our command starts with a dollar. Then we can also check if I think then we anyhow can split, right? So then let's just split it, and we say command.split with and we split this up into parts, and we can just say val, and we can just say the command. I think we can still rather call this line, and we'll call this line here as well. And then we can say the command. The command is actually the parts at position 1. And if we have an argument, val argument, then the argument will be if parts.size greater 2, then we will have a part, otherwise the argument will be null. We need to deactivate this disable completions. Then we check if our command is equal to cd. Then we want to take the argument, and we want to tell our path. So let's say if argument is equal to slash, then the thing we will do is, I think we can just say path is equal path.clear. Can we clear? Yeah, then we clear it. And if the argument is this one, cd without yeah, we can just check that here. If the argument is this, in the else case, we want to say path dot last. Can you do something like add last? Yeah, then we'll not have a mutable list, but we have a dequeue here. Dequeue. We used it, I think, here already. Array dequeue. Okay. The array dequeue. At last, and we'll just put the argument there, and we'll put it we put it with the double exclamation mark. So if there is no argument given for cd, we are pretty happy to throw an error. What we almost forgot is the else here. We can also have the dot command, and then we would say path dot remove last, then we remove the last one. Good. Should we actually do a copy of that? We can do a copy when we assign the file. So this now should keep track of all our files. And if the line of our folder navigation, and there we also have the command which is equal to ls. I think there is actually nothing different, so I'm pretty sure for now this is actually something we can ignore. But if we have anything else behind the dollar, we will throw an error. Nothing behind the dollar. I think we can just ignore this. We're actually pretty fine with it. Else. And now we have two possibilities, I think. We have the line starts with a dir, and we would also split if we start with a dir. Then we have the parts of the line, and we have the directory name, which is equal to parts at position 1. And we have the else case. In this case, we are a file. We also want to have the split, but in this case, we have the file size. which is the 0, and the file name, which is the 1. And the file size, in our case, this, I'll put it to a long. So, the first part should already kind of be fine. Here it now gets kind of interesting because this directory, what does it do for us? It might even also be fine to ignore it because I mean, it's nice to know, but if we don't navigate into the directory, we don't really have an idea how many, what can be in there. So just say nothing. To do nothing. Just put that here. But we here get the file size, and we'll also get the file name. And we actually know our directory path. And now I would yeah, that's the question. I think we have our path, but it would be also pretty cool if we actually store our directories we found. Because then we could list them. We need them to nest the files, of course. Of course. So this is navigating out. So I would, for now, create the small data class. This is the val, it's the directory name. Do we keep name? We can keep name and path. Or do we need the path? Let's say directory path. And we also keep files, and this is a need to put that as a string. And we have val files, and this is a mutable list of files file. Find that, and the data class file, which has val size, val file name, which is a string, and we have a val file size with a long. And this is the data class directory. And if we do the ls command, if we do the cd, we always have the path, and we can here keep a map of a mutable list. That doesn't make of files, and we also have a subdirectories, which is also a mutable list of directory. Then we can just have a method that's called val total dir size and directory size while directory size get, I think you can write directory size. Anyway, get is equal to files dot map dot it dot size dot sum plus subdirectories dot map dot it dot dir size dot sum. Fun. Get dir size. I'm a bit unsure about the syntax currently, so just make it a method, but it could also be a property. Return, and this should return along. And this is then also get directory size, and then we can have this. It's never called, well, fine for now. And we can just construct the file here. File, file name, file size. And we want to have something like a current directory. Which I would just say is var current directory. It's directory. And I would say we can maybe start with root. Let's just check what our input does. Yeah, it does the same. So, and we can have I would also want to keep a map of directories, path dir map, and that's just a map, mutable map from to have it as a string. We can actually string to directory. Is this hash map in Kotlin as well? It's hash map. Ah, no. Mutable map of. Getting almost forgetting it here. So it is of course a hash map, but then we can say path dir map, where we say put, and we put in this. Do we have the slash? No, we keep it empty. And we put in here, we put in a directory with nothing, and all of those usually should be mutable list, and also this should be a mutable list of as a default. And then we can, let's just call this root, while root is equal to this, and we can just put in root in our path map here. Path is root, and we're done. Now we can even say root dot directory path, so this is nicer. And the current directory is root, and we do this. If we go here, then we say the current directory. We can clear the path before. In general, I think we can do this because it always means a change, right? So we can do the current directory is the path dir map, get or put. Now if we change to a directory, we already, no, we don't need to know if it, well, in our case, we should know that it exists because we do the ls. So let's just assume we need to know We'll assume that for now. We'll anyhow get a crash here. We say get value. And the current directory is the path.join. Join to string. And we actually don't really join to string. We just want to supply the separator, I think. Yeah. Join to string. And we just put in the slash and should be fine here. So we try to get the path value and set this to our current directory. And if we are successful setting this, we can then now go here. And for example, we need to do something here. We find the directory and we would say child subdirectories dot add, and we'll add another directory. That's the question. We could actually have a listing multiple times. For this is easy, so we can just have the files as a set here. Yeah, we just can make them sets. Set. And we can also make mute able set. And we should override the equals and hash code function. Is the only thing we want to include here is the directory path. And the same we want to have for the file. For the file, it's not so much important, but because the file size most probably won't change. But we'll have this issue. We would have an issue. So if we list the directory multiple times, we don't want to add it to the current directory if it already exists there. So that's why we can't just create the directory here. The thing is, I'm a bit unsure if it would replace it. But we can do the following. We can actually just say directory dot directory name, and we can then say current directory dot subdirectory it contains. We can check this, say this is our new dir, or found dir, and if it contains the found directory, then we are already fine. Only if it not contains it, we want to add it. Add this to our subdirectory, and for the file, we'll just copy that and say this is our file, and we have here files, we have here files, and we have here file, and we have here file. And now everything is added into those directories. We have the size computation here. So I think we should actually have a proper file tree. No, we won't, because this is the path. We need to be careful here. We want to get the full path, which is the path map. To join. So we need to get our, call this current path. And we want to get the current path. Directory name, this is fine. But we want to have the path, which is the current file. We'll join that. And we think we can maybe we are able to do that. Just give that a try and say directory name. Can we do this? Yeah, and then we want to have the path here. And we are, I think, good to go. We need some kind of return value here. Let's just check our computation. So whenever a directory exceeds this, to begin, find all of the directories with a total size of at most. That means we need to traverse our things. But we now need to flat this all out. Well, we have the path dir map here. And this is whenever we traverse, we actually have all the directories in this map. We should. We totally should. Even if we go in there, we should have them in this map. Right? Well, if we have traversed it, well, path dir map is not even filled by now, right? That's actually kind of true. So we should really do this here as well. That means well, we expected to, so let's say path is equal to the found directory. The question is if we still need to keep track of the subdirectories, but I think we need to for this. We won't really need the path in there. Might even make sense to step that back. But for now, also don't see I don't think we need the path in the directory anymore if we do it like that, but we'll see. And then we'll just take this and should we map it already? I would say we filter it first to size, path filter. We're only interested in the values actually. Dot filter get directory size greater 10,000. You can put an underscore here, and then we would like to sum of it dot get dir size. I'll just call in the lack of a better name, dirs dot sum of it dot get dir size to string return. And variable is never modified. Yeah, that's true, because we modified while adding and removing items. Yeah. Let's give it a run. Not that correct. So let's check back. So we are receiving a much higher value. And I think the dir size must be smaller than that. If that was the mistake, I'm really happy about it. Yeah, not really. So to begin all of the directories with a total size of at most, find all directories with a total size of at most, then calculate the sum of their total sizes. Yeah, okay. The thing is, we'll just give it a try and see if we find out how our path tree works or not. So if we have the path dir map here, let's for example check the E folder. It should only contain 0 subdirectories and 1 file, and it's the file I with a size of 580. That's correct. Now let's check D. D should also be fairly easy. D should have some files. $6,000, $72,000, and no subdirectories. So nothing from D. So nothing from D should be included, but D is included in root, but that's fine. And then we want to have A, and for A it now gets interesting. For directory D we can say evaluate expression dot dir. Just think of entry set. Path dir map access d dot direct dot get dir size. That's correct. Then let's check that for A. $853, yeah. This, as far as we go, is correct. Oh, there is 0. 100,000. So now you're ready to choose a directory to delete. The total disk space available to the system is 7,000. To run the update, you need unused space of at least 30,000, 30 million, whatever. You need to find a directory you can delete that will free up enough space to run the update. In the example above, the total size of the outermost directory and thus the total amount of used space is. This means that the size of the unused space must currently be, which isn't quite the required update. Therefore, the update still requires a directory with total size of at least. The update still requires a directory to be deleted before it can. Okay. To achieve this, you have the following options. Delete directory E, which would increase blah 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 blah. Directories E and A are both too small. Deleting them would not free up enough space. However, directory D and / are both big enough. Between these, choose the smallest. Increasing unused space by find the smallest directory that, if deleted, would free up enough space on the file system to run the update. What is the total size of that directory? So if I have now understood correctly, we can just copy over that method into our part 2. We go to our run thing and call it P2. And what we now should do is we can now go to path dir map and get our root directory, the all data size. Then we have the val required. The total disk space is available. Total space is not doing the same mistake again. And update size is this one. And we can say get value, so we get rid of the annoying null thing here. And what we now need to know is we need to have delete min is our total space minus our all data size is what's free for now. Well, free now, free space now is total space minus all data size, and that means we need to delete at minimum the update size minus the free space now, and we can choose, and then we need to choose the smallest. So the thing is, we'll then just, not really sure if this filtering is still applied. I would suggest no. Yeah, I will say the filtering is gone. And what we now take, we take our direct path to dir's values, and it's relatively easy. We can now filter them, and everything that where the dir size is smaller than what we need to delete as a minimum doesn't really count. And then we can sort this by it.get dir size. And after that, we have sorted it, and then we have the minimum on top, which would be 0. What is the total size of that directory? And then I think it's a list. Can we access it like that? Let's give it a try. Get dir size and return this as a string to string. And we'll also need to make sure we have our input set up. And this would increase the space by that. So that's our example.check for this level. Locate. Yes, no. We'll need to change it in here. And then let's give it a run. The get tier size must be small. The delete minimum, yeah. Those equals, those comparison signs today, definitely not my friend. So, submit this. Luckily, we are done. Yeah, actually, quite some troubles with some numbers today. But we are through the example. I found it pretty cool. I really liked the file traversal. And well, let's clean this up a bit. So, what did I not like here? It's pretty nice. This stuff, I think we can just make this a method. Refactor, introduce variable, blah 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 blah, extract to method, extract interface, inline. Function to scope. I think that's the old extract to method. Select target. We would actually say this file, so we can reuse it in both. And yeah, well, we actually file structure. So that's a pretty neat method. We can move that down here. Can check the calling. The calling looks like this, and that's basically all we need for this one here, if I'm not mistaken. And maybe as explanation, what we did here with the file name. So we had hash code and equals, only using the file name, or for the directory, its path. So that I'm pretty sure the example wouldn't be that tricky. But if we here would just add them, it might, and it can be that we get two listings for the same directory. And if we have those, we would actually not, we would actually count files twice and stuff like that. I mean, we could also prevent it by checking if you already have done an ls on this file. So there's plenty of room to kind of make it a bit more efficient. Yeah, let's say we look if we can do that somehow. So if we have here the path map, we join them together, and we knew that we've been here already. So if we current file, this one gives us the file path, and if we know, do we know if we have been here? We actually know if the folder is empty. I mean, we can set the visit flag. We could actually set the traversed flag, so that if the current file is traversed, we don't do anything with the listings. And if we, but when do we know we have traversed it? We can check, but we we have a hard time checking if we finish the traversal. But I think if we started one, there is no option without having it finished. Yeah, so we could actually set here a variable which lets us know if we've already traversed it. And if we have traversed it, then we could also for this get dir size, we could also cache the result, because currently we are computing this quite some time, and this is also a recursive method. So yeah, we should definitely cache this as soon as we know we have fully found the subdirectories in the directory. But the thing is, if we do that in the parser here, we would always kind of need to finish the directory before changing, which would definitely be nicer. But for now, I wouldn't implement it. I think it makes the solution more complex than it is. But for a hard example, I would have implemented something like, or for a larger example, like caching the file size definitely, because it's recursive, and we call it quite a lot. And what also could have made sense is to basically cache, or to have a quick lookup if you already traversed the directory or not, for adding those up. Currently, this is done for with this logic here, but I'm not even sure if we ever encounter this, that we list the directory twice. Thinking of the day and the complexity of an event of code, I think we would not have had this in today's example. So then, thanks for joining in. Have a nice day. See you tomorrow.